Today we are going to see about factor theorem. The factor theorem states that if p of x is a polynomial of degree n greater than or equal to 1 and a is any real number, then x minus a is a factor of p of x if p of a equals to 0, and p of a equals to 0 if x minus a is a factor of p of x. Now here you have a term named as factor. Now what does factor mean? Okay, now let me tell you an example. If we divide 6 by 2, the quotient will be 3. 2 3s are 6, the answer is 0. So we can say that 2 is factor of 6. So if we divide a number by another number and you get the answer as 0, you can say that the divisor is the factor of the dividend. In the same way, if we divide for polynomials, if p of x is divided by x minus a and you get the remainder as 0, you can say that x minus a is factor of p of x. Okay, let me show that with an example. P of x equals to x cube plus 3x squared plus 5x plus 6. So here x minus a, that is, you are going to divide this number by x plus 2. So you have to show that this x plus 2 is factor or not. So first we have to find the remainder using the remainder theorem. In our previous video we have seen about the remainder theorem and we have solved some problems. So you can go and check the video. So now we are going to find the remainder. So to find the remainder, first equate the g of x equals to 0. So x plus 2 equals to 0, where x is equal to minus 2. Now substitute this p of minus 2 in p of x. In the place of x, you are going to substitute minus 2. You will get minus 2 the whole cube plus 3 into minus 2 the whole squared plus 5 into minus 2 plus 6, which is equal to minus 8 plus 3 into 4 plus this is minus 10 plus 6. So you get minus 8 plus 12 minus 10 plus 6, which is equal to minus 8 plus 12 is 4, 4 minus 10 is minus 6 and plus 6 will get 0. Therefore here the remainder is 0. So x plus 2 is a factor of p of x. So first understand factor theorem and remainder theorem. Don't get confused. To get the remainder, you use remainder theorem, and if the remainder is 0, then the divisor is the factor of p of x. This is the factor theorem. So here we are given that p of x is a polynomial and you are going to divide by another polynomial, that is x minus a. If the remainder is p of a is 0, then you will say that x minus a is a factor. If the p of a, the remainder is 0, then obviously x minus a will be a factor of p of x. So you can easily differentiate remainder theorem and factor theorem. Now we are going to solve problems from exercise 2.4. Determine which of the following polynomials has x plus 1 a factor. So they have given 4 questions. We'll see the first one. It is x cube plus x squared plus x plus 1. So if you want to find the x plus 1 is a factor of this p of x, we have to find the remainder first. If the remainder is equal to 0, then we can say that this x plus 1 is a factor of this p of x. So p of x equals to x cube plus x squared plus x plus 1. Now x, we are going to find the 0 of x plus 1, that is x plus 1 equals to 0. Transposing 1 to the other side, we get x is equal to minus 1. Now we are going to substitute this x value in the place of x in p of x. So p of minus 1 equals to minus 1 the whole cube plus minus 1 the whole squared plus minus 1 plus 1. Minus 1 cube is minus 1. Minus 1 squared is plus 1. Here you have minus 1 plus 1. So minus 1 plus 1 becomes 0. And minus 1 plus 1 becomes 0. So you get answer as 0. Therefore, x plus 1 is a factor. We will solve the second problem. The question is x power 4 plus x cube plus x squared plus x plus 1. So here p of x equals to x power 4 plus x cube plus x squared plus x plus 1. So we are going to find the 0 of x plus 1, that is x is equal to minus 1. So p of minus 1 equals to minus 1 the whole power 4 plus minus 1 the whole cube plus minus 1 the whole squared plus minus 1 plus 1. So minus 1 to the power 4 is 1. Minus, because minus 1 cube is minus 1. Here minus 1 the whole squared, so it will become plus 1. Here you have minus 1 plus 1. 1 minus 1 is 0. Here 1 minus 1 is 0. You have balance remainder as 1. Here the remainder p of minus 1 is not equal to 0. Therefore, by factor theorem, x plus 1 is not a factor of p of x. We will solve the third problem, that is p of x equals to x power 4 plus 3x cube plus 3x squared plus x plus 1. So 0 of x plus 1 is x plus 1 equals to 0, which gives you x is equal to minus 1. Substituting p of minus 1, you get minus 1 to the power 4 plus 3 into minus 1 cube plus 3 into minus 1 squared plus minus 1 plus 1. So minus 1 to the power 4 is 1. Minus 1 cube is minus 1. Minus 1 into 3 is minus 3. Minus 1 squared, you will get 1. 1 into 3 is plus 3. Here minus 1 plus 1. So minus 3 plus 3 can cancel it. Minus 1 you have plus 1. So the remainder is 1. Therefore x plus 1 is not a factor. Fourth problem is x cube minus x squared minus of 2 plus root 2 into x plus root 2. So x plus 1 equals to 0, which gives you x is equal to minus 1. So p of minus 1 equals to minus 1 the whole cube minus minus 1 squared minus 2 into x. So you can write this p of x as, make it simpler, x cube minus x squared minus 2x minus root 2x plus root 2. Here you have minus symbol, minus into 2x, and you have minus into root 2. So I have written it as minus root 2x. Therefore, minus 2x is 2 into minus 1 minus root 2 into minus 1 plus root 2 minus 1 minus, here minus 1 the whole squared is 1, minus 2 into minus 1 is plus 2, minus root 2 into minus 1, that is plus root 2 plus root 2. So minus 1 is minus 2 plus 2 plus root 2 plus root 2. You will get 2 root 2 as the answer, which is not equal to 0. Therefore, x plus 1 is not a factor. We will do the second problem. Use factor theorem to determine whether g of x is a factor of p of x in each of the following cases. The first problem is p of x equals to 2x cube plus x squared minus 2x minus 1, and g of x is x plus 1. So we have to show that this g of x equals to x plus 1 is a factor of the p of x. So now we are going to find the 0 of g of x. So 0 of x plus 1, that is x plus 1 equals to 0, x is equal to minus 1. Now we are going to substitute the x equals to minus 1 in p of x. That is p of minus 1 equals to 2 into minus 1 the whole cube plus minus 1 the whole squared minus 2 into minus 1, which is equals to 2 into minus 1 cube is minus 2 plus 1, minus 2 into minus 1 is plus 2 minus 1, which is equals to minus 2 plus 2 will get 0, 1 minus 1 is 0. So the answer is 0. Therefore, g of x is a factor of p of x. Second problem is p of x equals to x cube plus 3x squared plus 3x plus 1, and g of x equals to x plus 2. So x plus 2 equals to 0, x is equals to minus 2. Now substitute p of minus 2 in p of x, that is minus 2 the whole cube plus 3 into minus 2 the whole squared plus 3 into minus 2 plus 1. So minus 2 the whole cube is minus 8 plus 3 into minus 2 the whole squared is 4. 3 into 4 will be 12 minus 6 plus 1. So you will get the answer as minus 1, which is not equal to 0. Therefore, g of x is not a factor of p of x. Third problem is p of x equals to x cube minus 4x squared plus x plus 6. G of x equals to x minus 3. Now 0 of x minus 3 is x minus 3 equals to 0. X is equal to 3. Now p of 3 equals to 3 cube minus 4 into 3 squared plus 3 plus 6. 3 cube is 27 minus 4 into 9 plus 3 plus 6. So you get 27 minus 36 plus 3 plus 6, which is equal to 27 plus 3 is 30, 30 plus 6 is 36. 36 minus 36 is 0. Therefore, g of x is factor of p of x. We will solve the third problem. Find the value of k if x minus 1 is a factor of p of x in each of the following cases. The first problem is p of x equals to x squared plus x plus k. So here they have given as the g of x, that is x minus 1, is a factor. So if x minus 1 is factor of p of x, then we can say that p of 1 equals to 0. If x minus 1 is a factor of p of x, then the remainder p of 1 is 0. So by factor theorem, we can say that p of 1 equals to 0. So we are equating the p of x equals to 0. So we are going to substitute 1 in the place of x here. So p of 1, that is 1 squared plus 1 plus k equals to 0. So here 1 squared is 1 plus k equals to 0. 2 plus k equals to 0. Therefore k is equals to minus 2. Second problem is p of x equals to 2x squared plus kx plus root 2. Here the same steps you are going to follow, because here also x minus 1 is a factor. So you are going to find the value of k here. So substitute in the place of x, you are going to substitute p of 1 equals to 0. So p of 1, you get 2 into 1 squared plus k into 1 plus root 2, which is equals to 1 squared is 1, 2 into 1 squared is 2 plus k plus root 2. So we are equating that to 0. So taking 2 and root 2 to the other side, you will get minus 2 minus root 2. You can leave the answer like this, or taking minus as common, you can write 2 plus root 2. So the answer is k equals to minus of 2 plus root 2. Third problem is p of x equals to kx squared minus root 2x plus 1. So x minus 1 is factor. Therefore x equals to 1. So p of 1 equal to k into 1 squared minus root 2 into 1 plus 1 equals to 0. Therefore k minus root 2 plus 1 equals to 0. K equals to root 2 minus 1. Fourth problem is p of x equals to kx squared minus 3x plus k. Substituting p of 1, we get k into 1 squared minus 3x, that is 1 plus k equals to 0. K into 1 squared is k minus 3 plus k equals to 0. K plus k is 2k minus 3 equals to 0. Keeping 2k this side and transposing minus 3 to the other side, you get 3. K is equal to 3 by 2. So to check the answer whether the value of the k we have found is right, you can substitute the value of k in the place of k in p of x. You will get the remainder as 0. In the next video, we will discuss about the factorization of polynomials. Subscribe to my channel to get the new video updates.